Dear friends, welcome to VK Lectures. Today we are going to study mathematical physics. As a continuation of the last class, we are studying more about complex integrations. We can study this complex integration over two sections. Is along a curve and along a straight line. So first, let us look how along a curve we can arrive at an equation to find the complex integration along a curve. Let z is equal to r e raised to I theta. We need to find integral c f of z dz along a curve. Let z is equal to r e raised to I theta. Then dz is equal to r e raised to I theta into I d theta. So this integral c f of z dz gets converted into integral f of theta d theta. Then example for this along a curve is contour C 0 to pi we can take. So integral pi to 0 f of theta d theta. Second example is like this, we can take here 0 pi by 2 minus pi by 2. So integral pi by 2 to minus pi by 2 f of theta d theta. Then B along a straight line, like this, a straight line if you are taking. Let z is equal to x plus iy, then dz is equal to dx plus I dy. This can subdivide into 2 along x axis and along y axis. Here y is equal to 0, here x is equal to 0. So dy is equal to 0, dx is equal to 0. So problems based on this we can solve. Integral c z square dz, contour is a circle, modulus of z is equal to 1 from theta is equal to 0 to pi by 3. Solution you can write as let z is equal to r e raised to I theta. Since here r is equal to 1, dz is equal to I e raised to I theta d theta. So integral c z square dz is equal to integral 0 to pi by 3 e raised to 2 I theta into e raised to I theta into I d theta. So that is equal to I integral 0 to pi by 3 e raised to 3I theta d theta. So this is equal to I into e raised to 3I theta by 3I within the limits 0 to pi by 3. So this is equal to e raised to I pi minus 1, that is equal to minus 2 by 3. Second problem, integral C 2z plus 3 divided by z dz, where contour is given as upper half of a circle in clockwise direction, where is a modulus of z is equal to 2. Solution, if you are taking like this, pi to 0, z is equal to r e raised to I theta 2 e raised to I theta. So dz is equal to 2I e raised to I theta d theta. So integral C 2 into 2 e raised to I theta plus 3 divided by z, again 2 e raised to I theta, into dz is 2I e raised to I theta d theta. This is equal to I integral pi to 0 4 e raised to I theta plus 3 d theta is equal to I into 4 e raised to I theta divided by I plus 3 theta within the limits pi to 0. So this is equal to I into 4 1 by I plus 4 by I minus 3 pi. So this is equal to I into 8 by I minus 3 pi. So that is equal to 8 minus 3 pi I. Then third, evaluate integral C modulus of z dz, where contour is given as left half of a unit circle, Solution, zero to pi by 2 to 3 pi by 2 So here modulus of z is equal to 1. So z is equal to r e raised to I theta, dz is equal to I e raised to I theta d theta. So integral minus pi by 2 to pi by 2 I e raised to I theta d theta, that is equal to I into e raised to I theta divided by I within the limits 0 to pi by 2, that is equal to 2I is the answer. Fourth question, evaluate integral C z divided by z bar dz over the contour -2 -1 0 1 2 solution First of all, we need to redraw this contour. Let this be 0 to pi, this curve, and here also outer curve is 0 to pi. So 0 to pi here. This is the first part. This is the first part. And we can take this as second part. And we can classify this as the third part. And this as fourth part. So like this, we need to part the diagram into different classes, and we can move along to the answer. In the first part, along a straight line, z is equal to x plus iy, that is along x-axis. So since it is along x-axis, y is equal to 0, therefore dy is equal to 0. Then dz is equal to dx, and z bar is equal to x minus iy. Then integral x divided by x dx is equal to integral minus 2 to minus 1 x, that is minus 1 plus 2, that is equal to 1. Then comes the second part. It is along a curve. Z is equal to r e raised to I theta, where r is equal to 1. Then dz is equal to I e raised to I theta d theta. Then integral pi to 0 e raised to I theta divided by e raised to minus I theta I e raised to I theta d theta, that is equal to I integral pi to 0 e raised to 3 I theta. So that is equal to I e raised to 3I theta divided by 3I within the limits pi to 0, that is 1 by 3 into 1 minus e raised to 3 pi I, that is equal to 2 by 3. For the second part, we got the answer as 2 by 3. Then for the third part, that is along straight line, so integral x by x dx, that is equal to integral 1 to 2 1 dx, that is equal to 1. Then for the fourth part, it is also along a curve, therefore integral 0 to pi 2 e raised to I theta divided by e raised to minus I theta to 2I e raised to I theta d theta, that is equal to 4 by 3. So all four parts have been evaluated. So therefore, when we are taking the total of the four parts, we got 1 plus 1 plus 2 by 3 plus 4 by 3, that is equal to 2 plus 6 by 3, that is equal to 2 plus 2 is equal to 4. Then comes the next question. Evaluate integral over the contour dz z square, where the contour is defined as unit circle in anti-clockwise direction. Anti-clockwise direction. So, solution. First of all, we need to draw the circle. We need to draw the circle with 1 as radius. So, integral dz z square is equal to 0. So, we know that closed integral f of z dz is equal to 0. Here, z square is an analytic function. Then next question. Integral over c dz e raised to z, where the diagram is given like this. 1, 1 here, y is equal to 0, dy is equal to 0, 1, 0, here, 0, 0. So from here to here we are taking. So solution is, here e raised to z is analytic. Therefore, y is equal to 0 and dy is equal to 0. So, z is equal to x plus iy, that is equal to x. Since y component is 0, we have z is equal to x. Therefore, dz is equal to dx. Hence, we can integrate as integral dx e raised to x within the limits 0 to 1. So, that is e raised to x within the limits 0 to 1 equal to e minus 1. Next question. Integral c z dz. Diagram is given like this. Here it is 0, 0. Here this is 1, 0. Then this is 2, 0. Solution. Y is equal to 0. dy is equal to 0. So, z is analytic. So, z is equal to x plus iy. Since y is equal to 0, z is equal to x. So, dz is equal to dx. So, we can integrate within the limits integral 0 to 2 x dx, that is equal to x square by 2 within the limits 0 to 2, that is equal to 2. Next question. Integral over c is z square e raised to z dz over the rectangle. Here minus 1, 0. Now minus 1, 0. So we have a rectangle like this. this is 0 1, this is 1 0, this is minus 1 0. So solution of this is, since z is equal to x plus iy, dz is equal to dx plus I dy, so it's equal to integral minus 1 to 1 x square e raised to x dx is equal to 2 into integral 0 to 1 x square e raised to x minus 2x e raised to x plus 2 e raised to x. So we can write as minus 1 to 1 x square e raised to x minus 2x e raised to x plus 2 e raised to x. So we got the answer as e minus 5 e raised to minus 1 or 5 by e minus e. This is a very important question. Then over to the next question. Integral over c e raised to z dz. The contour is given as this. One zero minus 1 0 like this. So solution is we need to redraw the diagram again, and we need to define minus 1 to 0 and 1 to 0. So from here to here and here to here, this is 0 to pi. So hence e raised to z is analytic. We can write integral minus 1 to 1 e raised to z is equal to raised to 1 minus e raised to minus 1, that is equal to e minus 1 by e, that is equal to e square minus 1. So we have completed complex integration over straight line and a curve. In the next class we will study along semi-infinite circle. Thank you.